Hello there once again, it's Xpresso Mechanic here with another tutorial for you. This one being a bit of a departure because there's no Xpresso in it. It's purely going to be about Python, this one. We're going to create a Python effector. And what we're going to do, we're going to use that to create a kind of a 70s kind of display that you might have seen in shows like Blake 7 or possibly the Tomorrow People, those kind of shows from the 70s. But anyway, if we head over to the object list, you can see that this is made up of two cloners. The first cloner is the screen. It's a futuristic kind of honeycomb affair. And then the hexagons here are like a holographic picture elements. That's the idea behind them. And what I'm going to do is randomly choose a batch of these, display them for a certain time interval, and then repeat the process. So it will be a constantly evolving display of a random number of hexagons. Okay. That's what we're going to do. So without further ado, let's get started on that, and we'll grab in an effector. We'll grab a Python effector. We need to give that effector to our second cloner, so we'll just put that in there. And straight away it starts to do something which we don't want it to do, so we'll go to the effector, change from parameter control to full control, and something else happens. And then from here, what I'm going to do actually, I'm just going to go to my layout. So I've got a coding layout. So I can bring that in and I can open my Python code in there. And down at the bottom, I've got a console set up as well. So we'll just change that to Python, get rid of that. Okay, so we'll get rid of this loop because we don't need that at the moment. Hit the execute button and that brings everything back to normal. Right, so the first thing we need to do, because we're going to generate a random number to decide how many hexagons we're going to select, or rather the index values of the hexagons that we're going to select, we need to import random. And that comes in from the Python module, not the Cinema 4D module. Okay, so we've done that. Moving on from here, I need an array for, well, it's the flag array, the MoData flag array. So I've got to bring that in. Don't worry too much about this at the moment, but I'm just going to say far is equal to, and then copy this much, and then just add flags to the end. And if you don't know what mar and far do, the mar is the matrix array, and the matrix array just gives us information about the locations of the hexagons, that kind of thing, and their offset values, those sorts of things. So it's basically the positional information and that sort of stuff that we get from the matrix array. And the flag array, well, that has a number of different functions actually, and you can find out more about this in the SDK. But what we're interested in doing with it is switching our clones on and off, and that's one of its functions, so that's why it's there. But we'll see more on that later. Right, so our next port of call is to define a couple of variables, but before I do that, I need to go into my user data and add user data. I need a couple of these. So I need interval, which is going to be an integer because it's going to be based on frames per second. And what I'm going to do, I'm going to start that at, say, well, we'll go from 1 to 100 actually, that'll be fine. And then we'll start with a default value of 5. That should be fine. So that's okay. And what I'll do is just copy that down. And then this will be hexagons. So this will be the number of hexagons that we're going to display. Again, it's an integer. We'll say, well, minimum of 1 I think is fine. And then 40 max is about what I think we'll go for. And we'll start it at 10 as a round number for the default value there. Before I go any further, I'm just going to make these into integer sliders. Same with the interval there. And then that should be fine. So we go to our user data. We've got those two in there. That's great. Right. So from here then we can define a couple of variables. So I'm going to say visibles is equal to, and it will be hexagons. So we just need to pull that one in from there and just drop it in there. And then put op in front of there. So that's the first variable defined. And then following there, invisibles. This is equal to. Now, we've got a couple of, or we've got something up here that's important. We've got a counter up here. Now, if we just print count, this will give us the number of clones that we've got in our array. It's giving me an error because I haven't defined invisibles. I'm just going to take that away for a minute. We'll just have a look at this first. So if we just execute that, yeah, so it tells us down here that we've got 50 clones. And if we go to the cloner over here and turn on the index values, you can see that we've got a 0 in the bottom left corner. In the top right corner, we've got 49. So we've got 50 clones, but they range from a value of 0 to 49. And that's important later on, and you'll see why. So that's our count. Another thing I actually need to add is a frame variable, which I'm going to put in here. I'm going to say frame is equal to doc get time get frame doc get FPS. Actually, I need an open close there. That's it. And then what we'll do to show you what this does, if we just say print frame, what this will do is actually get the timeline down here. We'll actually get the frames per second from the timeline. So if I reset that to 0, I get a 0. And if I just grab a hold of the timeline and move through, it will show you how many frames I've gone through. And we can just run the timeline and get the same result. So you can see it's grabbing the frames from the timeline there. So just take that away, because that's going to be important to us. Right, so now we need to define invisibles. So invisibles will be equal to our count value minus visibles. And we also need to say -1, because if we don't, when we set our user data, if we were to take the hexagons down to 1, we'd actually get no visible hexagons unless we take away the 1 from visibles. It's a minus times a minus, minus times a minus is a plus. So it actually adds 1 clone back on, which is a bit of a strange concept to grasp. I didn't quite understand why that was at first, but it is a bit of a weird one. We can perhaps demonstrate it and have a look at it when we get further in. But anyway, let's carry on from here. So moving on from there, what we need to do really is just add a global variable, which will be indexes. And these will be the indexes of the clones that we're going to actually remove from the display, not the actual indexes that we're going to display. Before I go further, I'm just going to come down to the bottom here and say, I'm just going to copy the whole thing actually, you just paste that in there and then just simply change this to flags and this to far, and that will update both arrays, and that's fine. So we just need to do that. What I'm also going to do is define indexes, which initially is an empty list, so just an open and closed brackets for a completely empty list, and we're going to populate that list with the index values that we're going to choose from our display here at random, and then those index values will be made invisible. That's what we're going to do. So let's move on from here. We can now define our first function. So I'm going to define generate hexagons. And we start with a while loop. So we say while the length, which is what the len means, the length of indexes is less than or equal to invisibles This is where we generate a random number, so we say RND for random is equal to random dot rand int, which is random integer, whole number. As our indexes are, they're all whole numbers, so a random integer is what we need to generate. And that's going to be basically from 0 to I'm going to say count -1. And again, I've done that because we're going from 0 to 49, not from 0 to 50. If we just left that as count and didn't put the -1 there, we would get an index. It would eventually choose 50, and we'd get presented with an index out of range error. So we must take that one off. That's very important. We can then say if random is not in indexes. I spelled not wrong. Let's just take that back. That's it. We can then say indexes dot append random. So this is quite an obvious piece of code. So it's just simply saying that if our random number that we've generated is not already in our indexes, we can add it to our indexes. That's all we're saying there. So quite a straightforward piece of code, that one. We now need a for loop. So we're going to say for I in range. Helps if you separate the words. Len indexes. Okay. And this is the most important piece of code, and certainly the most interesting piece of code. So we then say far indexes open brackets again, I double close. And then we say and equals squiggly line open brackets C4D dot mo gen flag underscore clone underscore on. Now what's going on here? Let's just have a quick look at what this function actually is here, because this is what we call a bitwise function. So let's just have a quick look at what's going on. So we now have a list of bitwise operators or integers in front of us. And we can see that there are a number of them, but we don't need to worry about most. The only one we're really interested in actually is the one's complement, which is at the bottom of the table. And as we can see there, we've got a squiggly line, which we've got in front of our brackets in our code, in front of the letter A. So let's have a look at the top of the table there. And we can see that A is equal to 0, 0, 1, 1. And the one's complement of A at the bottom is 1, 1, 0, 0. So the direct opposite, the inverse. So it's the equivalent of saying not, which hopefully you'll be familiar with, having seen a few of my Xpresso tutorials, because I use the not node quite extensively in those, and it turns a 0 into a 1 and a 1 into a 0. So if a mogen flag is switched to on any of the clones, then we're going to use this bitwise one's complement function to switch it off. And we've also got and equals in front of it. Well, we've got a bitwise and operator. So effectively then we're saying and is equal to not. It's kind of like not and. I don't quite understand why it needs to be a not and, but that's the way this works. And I'm not one to question why. I'd need that explained to me in a bit further detail by a real Python wizard. That would be great. But that's essentially what this is doing. It's literally saying if our indexes are in the indexes list, then we switch these clones off by using our one's complement. So hopefully that's given you a little bit more insight into what's going on here. As I say, I'm not Mr. Genius, I'm not Mr. Expert on this sort of thing. I've only found this stuff out by researching it myself. But that's what's going on. So hopefully that gives you a little bit more insight. Right, now we've cleared that up, let's move on to our next function. So now that we've generated our hexagons to be switched off, what we need to do is hold all of our hexagons that we've switched off in stasis. And we do that with another function. So we're going to define hold hexagons. And all we need to do there is copy this piece of code and put it into our our function. Let's just get that in the right place because the indent is not quite right. That's better. And that completes that one. It's a really simple function. It's just the same thing repeated. So this will be held. So while our interval in here is less, well, it's an interval of 5 that we've got in there. So every 5 frames, what we're going to do, and I'm going to set that up obviously in a minute because it's not done yet, but every 5 frames, what we're going to do is generate some hexagons to be held in stasis, and then this will hold them in stasis until we need to generate some more hexagons. That's what's going to happen. So let's take this a step further and say if frame is equal to 0, so if we're at the start of the animation over here, if we're here, if frame is equal to 0 or frame, and then we're going to modulo the result of this. So if frame modulo, and then we'll bring in the interval so that we can control the actual time interval from there. If that's equal to 0, which it will be every time the frames are equal to 5 or a multiple of 5, as it stands at the moment. Obviously we can change that to whatever we want up to 100. So every time we get a multiple of 5, we're going to get a 0. We can then say indexes must be reset to an empty list, and then we can generate hexagons. And if we put else hold hexagons, at any other time, which is going to display the hexagons that we've generated. So every 5 frames, or when the frames are at 0, we generate hexagons. At any other time, we just keep them on the screen as they are. Okay, and that's as simple as that. And that's the code for it. Let's see if it works. I'll bet there's some errors in it because there usually are. Now, that's not. I think I may have actually done this correctly. Yeah, I have actually. So if I just bring that up, you can see as I adjust my hexagons, I get more of them. Let's take it up to 10 where we said we'd set the default. So now we've got 10 hexagons, and you can see that I've still got the index values on at the moment, and you can see which ones have been chosen to display, but the others are all in the indexes list, and they're the ones that are being taken away by this line of code down here. Okay, so let's just run the timeline and see what happens. And it works perfectly. Does exactly what I said it would do. So hopefully this wasn't a baptism of fire. Let's just go into our cloner here and just turn the indexes off so that it's a little bit more pleasing on the eye. Just take it back and run it again. So there you go. So that's all working nicely. And we can change our time interval. Let's bring it up to about 40. So now it will only change every 40 frame. And we can bring our index values up so that we've got more to display. Or we can go much lower. So we've got quite a degree of control over the art direction of this just by using a couple of sliders here. So it's quite a nice thing to do. But yeah, that's essentially what we've created here. So let's have a quick recap. Let's see what we've done. So first thing we needed to do was import the random module from Python because we needed random numbers. We added a matrix array. Well, we've got a matrix array. We added a flag array, and the flag that we were interested in was the Mogem flag for clones on and off. So that was all we were bothered about there. And there's a number of other flags. If you want to look in the SDK, you can find out a little bit more about this. It might be as clear as mud to you, though, because it's a bit technical and there's not really any example code in there. But come on, Max, it'd be nice to have a bit more example code, hint, hint. But anyway, we did that. We got that array set up there. We got the frames from the timeline using this mouthful of a piece of code, which I usually type in wrong, but I managed to get right on this occasion, which is great. We then created visibles, and we used our data slider for the hexagons. We just brought that in there, and that was the visibles. And we were then created invisibles by saying we wanted our count value here, so our number of clones in the actual array, minus visibles minus 1. And let's just illustrate that now. So if I take away that -1 and I take this down to 1, let's see what we get. So I'll just take that back. Yeah, so we've got nothing on the screen now, even though I've got the hexagon set to 1. So there's just nothing's going to happen if we play it. If we set it to 2, we get 1. So you've got to take that -1 away from there in order to get the right amount of hexagons being displayed. It's because we've got 2 minuses. A double minus is equal to a plus. It's a bit of a strange thing. I always find that strange, because I'm not a mathematician, not by any means. But that's something you need to bear in mind when you're doing stuff like this. If you get something that looks a bit weird and you think, well, I've got 1 in there, but I've got nothing on the screen, just take off 1 from the variable that's controlling this stuff. But anyway, let's move on from there. So then we created a global indexes variable because we needed to use indexes down here, and we also need to use it in here as well. So, and in fact in both of our functions, so we needed a global variable for that. If anybody knows a better way, then fine, feel free to tell me. Please educate me too, because I'm not Mr. Expert at this. As Doa once said, you know, I'm not a guru. I'm just somebody who knows a little bit because I've done a bit of research into this, and I'm obviously very enthusiastic about it. Okay then, so we then moved on to defining our first function, which was to generate our hexagons, which wouldn't be displayed. That's the important thing here. So these that are not there, they're the ones that are in the indexes. So while the length of that indexes was less than invisibles, we then generated random numbers. If they weren't already in indexes, we added them to indexes. As simple as that. We then had a for loop, which iterated through all of our index values, and we made all of those index values invisible by using a bitwise function in this piece of code. The next thing we did was simply hold the hexagons. So anytime when these were once these were generated, we hold them for the length of the time interval, and that's what we're doing here. We simply copied this piece of code and put it in there to do that. And aside from that, we simply then said if we were at the beginning of our animation, or our frame interval had been reached, then we would clear our indexes list out, and then generate some more hexagons, and then update our display from there, and then hold the hexagons that we've been generating for the duration of the time interval. And finally, we just updated our arrays for our matrix and our data flags. And that's it. It's as simple as that. So not a particularly difficult expression to create, or a Python effector to create, I should say. And there you have it. There's the code for it. And yeah, it all works quite nicely. So I hope you've enjoyed this one, and that you've learned a bit from it and you think it was worthwhile. And I will be doing another one. There's another little one that I've got ready to go that's only got a single function in it, so it's in some ways it's simpler than this one, but it does something that's quite fun. So I'll see you very shortly when I've got that one done, and have a play with this and see if you can come up with something else for it. See if you can add, I don't know, different colors to the hexagons or something. Have a play, see what you can do. But anyway, I'll see you very soon on the next tutorial.